Kia ora Year 11 and 12. Here's the third holiday video. This one's from 1975 Scholarship Calculus, so I was born by the time this one was done, and it's a little bit harder than the last two that I've done. Still too easy for, it's kind of level 3-ish, or A level. It's a really nice wee question, and you'll notice it's got one of my favourite things in it. We have to prove that the function we work with up here is an even function. So sorry, I've just written this out really roughly. I haven't scanned it in from the place I found it. So we need to show that this is equal to this. So it's a typical proof. We're going to start on the left, and it's just algebra. We haven't even got any differentiation in here. But it's good practice for exponential functions, and it's very A-level-ish. So on the left-hand side, we've got this x over 1 minus e to the negative x minus x over 2. And we have to just work that through and do the obvious thing. So the first obvious thing is to get a common denominator. So let's start with that. I'm going to leave that negative power as a negative power. So we have 2x minus x times 1 minus e to the negative x. Right, now expanding out the brackets gives me 2x minus x plus x e to the negative x over 2 times 1 minus 1 over e to the x. Now why did I do that? Well, I looked at where I'm going, and I can see some things starting to appear already, but I know that I've got no negative powers in my answer, so I want to be moving the negative powers into positive powers. Don't skip too many steps here. You're likely to stuff it up if you do. So we've got x plus x plus x e to the negative x, and down here we've got 2, and again I'm going to get a common denominator. I'm going to get e to the x, take away 1. Now, cleaning up the denominator gives me a numerator of x times 1 plus e to the negative x times this e to the x from down here into 2 times e to the x minus 1. So you can see I'm just about there. Look where we want to go again. Sorry, hope I'm not making you seasick. No, we're not doing that, but yet we're doing this bit here. So we want to have an x over 2 times this. Expanding everything out gives me what I want. I've got x times e to the x plus 1, right? Because this times this gives me 1 over 2 e to the x minus 1 as required. Or you can draw the little square thing. Or you can do your smiley face. So the next bit of the question is actually more fun, which is to prove that this function is an even function. So we're asked to prove that f of x, I don't know what's happened to the stylus, f of x is equal to this, is even. So how do I do that? Well, for an even function, we're going to give a definition first. If a function is even, then f of x is equal to f of negative x. So I'm going to start with f of negative x, and I'm going to show that it ends up being equal to this. So f of negative x is equal to negative x times e to the negative x plus 1 over 2 e to the negative x minus 1. Right, so I'm going to get rid of those negative powers straight away. We're going to have in the numerator negative x times 1 over e to the x plus 1. And in the denominator, we're going to have 2 times 1 over e to the x minus 1. We need to get common denominators for both of those, but you can see that it's starting to look promising. So here we've got 1 plus e to the x. There's violin music in the background. I hope you like it. There we go. Right, now look what we've got here. Well, we've got an e to the x here, and we've got an e to the x here. So they simplify, and we get negative x times 1 plus e to the x over 2 times 1 minus e to the x. So I'm not quite there because I need to have e to the x minus 1. So how do I do that? Well, I just take out a negative 1 as a common factor, and I'm going to get this 1 plus e to the x over negative 2 times e to the x minus 1. Right, multiplying top and bottom by negative 1 gives me this x times e to the x plus 1 over 2 e to the x minus 1. And that's equal to f of x. Therefore, we've shown that f of negative x is equal to f of x. Therefore, f of x is an even function. That's it for now.